So Ajay, let's start that training. I don't think both the persons going to join. It's almost 10 minutes now. So let's start the class. Ajay, are you there?
Yes, Nita. Hi, Nita.
Okay. Probably you are speaking mute or something like that.
What?
Are you speaking in a mute or something? So
Yeah. Actually, I put in mute and I went for some medicine.
okay, okay.
So that's why I
So,
can.
so no worries. Today we are going to talk about K-mean clustering. Okay.
Yeah, okay.
So if we look at the machine learning, we can split it into two categories. That one is supervised learning and other is unsupervised learning. So far, what are the modeling we took for the last couple of classes, 4 5 classes, all fall under supervised learning. So supervised learning means we have a labeled variable, where we have the y is predicted there, and using the y and the x, we are going to predict how it's going to behave in a untested data, which is a test sample data. So in the supervised learning, in the data set, we'll have the output, what is exactly the output, and using the output and the input, we are going to learn the model, because we know what is the input, we know what is the output, how they are correlated, how the input triggers the output. That's what the supervised learning we learned sometime back. Probably the what are the KNN method or probably linear modeling. Everything fall under supervised learning. Yeah. In the unsupervised, modeling, we don't have any label or the output to to work on the model. It's a simple like we don't have any output. Only we are given the set of input. We are trying to cluster or we are going to do something on the particular data without looking out without having the output y. So that's why it's called unsupervised learning. In the unsupervised learning, there are multiple categories. One is clustering. That's what we are going to learn today. And there are other methods like, we have market-based analysis. Probably sometime, Friday we can look at what is market-based analysis. Or probably we can look at Saturday also, what is the market-based analysis. And there is another clustering called H cluster, hierarchical clustering. We call as H cluster, which I am not going to teach you, but probably I'll give a material to you so that you can read back. But the both K-mean clustering and H clustering works on the same methodology or framework. So once I teach you the K-means clustering, you can easily go back and refer the material on H clustering, and you can execute the code. Whatever we are executing for the dataset, we can execute the same for H-mean clustering. Okay. So there are a lot of other supervised learning, available in the world. Like we have something called, the social analysis. We are going to use whether Twitter or Facebook, to get the data and try to analyze the data. What kind of feed is coming. So that also will fall under unsupervised learning, or probably we can call it as STEAM analytics. Tomorrow we can look at one of the model called, the natural language processing. We are going to use some Twitter data to analyze some of the streaming, input coming into Twitter. I'll explain the step by step how we are going to, do the stuff. So let's concentrate on what we are going to do on unsupervised learning. So what is K-mean cluster? Okay. So first of all, what is a cluster? Cluster is nothing but a task of grouping a set of objects into a particular category. Example, if you have 1,000 data sets or 1,000 persons in your company, or your company has a set of customers. the cluster will work on this particular data set and make them into a separable groups based on the certain values or certain attributes the person of the data set has. So probably if you have around 1,000 customers in your company, probably the cluster analysis will do a grouping of the customers into 3 or 4 categories based on their attribute like their buying pattern, their salary, or probably their market value, etc., etc. It will make them into different groups, so that the distance between the group will be in a maximum way. So it try to maximize the distance between the group, but it will try to minimize the distance within the group. So you need to understand what is within the group and what is with the groups. So if we say within the group, when I'm dividing the data into 3 or 4 segments, all the points within the group has lesser distance compared to the points in the other group. And also when you are talking about the separation of the group, when we are doing the clustering, the main objective of the clustering is to maximize the distance between the groups. So if we say between the groups, when you are dividing the data into 4 groups, there will not be any overlap between the groups. So it will distinctly separate those groups in a maximum available possible manner. So that's what the cluster will do, cluster analysis will do, so that it is totally differentiate the groups within themselves. So did you get the point what exactly the cluster means, Ajay?
Yeah, got it, Seta.
Okay. So K means nothing but we are trying to divide the what are the data points we have into K set of groups by using the means within the group. So what we are trying to do, if we have the 100 data point or 200 data point, we are trying to divide the data points with K number of clusters, so K number of groups, in such a way that we are trying to find out the means within each group, and the points within each group should be closest to that mean. So if I'm dividing the data point into 5 groups, that means I have 5 means for each group. So 1 mean for each group, so totally 5 means. Means nothing but the average of all the points within the group. Okay. In such a way that how the cluster operates, each point within each group should be closest to their means when compared to other means. So we have mean 1, mean 2, mean 3, mean 4. If you take a 1 point in the group 1, the particular point should be closest to that particular mean rather than the mean from the second group. So it takes the mean as a calculating algorithm when deciding the K cluster or K groups. So using the K cluster, we can do a lot of segregation within the group. Like where are things we can use? They can cluster the documents. If you have set of documents, if you're working in a media company or somewhere else, you have this each and every the documents or movies. You have various the parameters. Various values like what is the movie title, what is the movie director, how long is the movie, whether it's a comedy movie. So using that, all that data points, it will try to segregate, whether the document or movie into separate groups. So you can cluster similar documents, like if you have a set of documents, it will segregate into sports document, it will segregate into political document. So you need to define what is the number of cluster you want to segregate just based on the features. So another example is cluster the customer based on the features. So if you have a set of customers in your company, what that K-means cluster will do, it will try to cluster the, group the customer based on features like, how many, what the salary range or what is the income range, which part of the customer, the location wise, etc. You can do the clustering. So, this kind of application used in a market segmentation also. If you are coming up with a product for a particular, industry, like, you are invented a product for high-end customer, but before doing that, making the product, you want to see which are the market I can target, like these are my target customers. And how you can identify the segmentation is based on the clustering. You can get all the customer data, feed it to the algorithm, and algorithm will come up with a way saying that who's your high-end customers, the average or medium segment customer and low-end segment. Then you can target, through proper marketing campaign, you can target the customers to buy that particular product. You can do the clustering algorithm. Okay. So there are various other methods we can do using cluster, mechanism. There are a lot of application uses, but these are the some of the things I already mentioned here. So far, any question, Kiran? Ajay? Okay. If there is no question, I'll move on to the next slide, Ajay. So, like I said, what is the K-mean clustering? So the overall objective of the K-mean cluster is, when you are given a set of points, a set of observations from any data set, anywhere else, the main objective is to divide the data set into multiple categories or multiple groups, and in such a way that the points within the group look similar, and the difference between between the group is on the higher side. And they joined back, Ajay?
Actually, there is a net problem in net.
Okay. So you want to go
so
back?
It was no.
Okay.
Just 15 seconds only it was disconnected.
Okay. Okay, that's fine. Okay. So the objective of K-means clustering is to, when given a data point, you want to come up with a separate groups of points in such a way that the distance between the groups or the difference between the groups on the higher side and the similarity within the group is on the lower side. So it's trying to minimize the difference within the group, and it try to maximize the difference between the groups. So you need to understand within and between. So if I say that this is my point, and I come up with 1, 2, 3, 4, 5 clusters. Okay.
Yeah.
Okay. So when I say the between the group,
I got between the group means like there is a difference between the two colors.
Yeah.
And within the group means the difference between in the same color.
Yeah. So it tried to minimize the difference in the same color, but between means it's trying to maximize the difference between the colors. So that's what it's trying to do. Okay. So how it does is it's based on we know that one of the typical approaches using the the equilibrium distance. So this is a calculation how it's trying to do the partitioning of the differentiating the cluster. So when we are given the k is equal to probably 1 to 10 or 1 to 20. So the formula says this is the equilibrium distance, right? So when you say the summation between number of clusters, so it's 1 to 10. This is what I'm going to give, and it's trying to find out the difference of between 2 points. So for each clusters, it's trying to find out the distance between the mean, that is MK, and the point. Okay. Mm-hmm. So this is the point within the cluster, and this is the mean of the clusters, and we try to find out the distance between the mean and the point for each group. This is for each group. This is for all the group 1 to 10. So if you are taking, first group, so then it will come to the next point. So here it takes all the points the first group and it try to find out the distance between, the first group and the distance mean. So for distance means, so this is nothing but, the mean of the first group and the points of all the groups. So it's trying to find out, okay, you have 1000 points, okay, I'm dividing into 10 groups. Or you have 100 points, I'm trying to divide into 4 groups. So the point will take the first group, okay, k is equal to 1, and it comes here, it will find out the distance between, all the 100 points, it will take all the whole 200 points, and the mean of the first group, okay. So the mean of the first group probably something, some points will be there. So I try to find out, when we do here, we have 5 points, correct? 1,
Yeah.
2, 3, 5 groups. So for first group, what we'll do, this is the first group, correct? It will have the mean. There's a point will be mean. The mean is nothing but the average distance of all the dark blue points. Okay.
Yeah.
So what it's trying to do, it try to find out the distance of all points, green point, red point, yellow point, and try to find out the distance between all the points and the mean of the first group, which is a dark blue.
Yeah. Okay.
Okay. And once it's done, so probably if you have 100 points, it will try to find out all 100 distance, correct?
Yeah. Okay.
Okay. Then it comes to second group, it does the same way. It's come to the light blue, it has the mean of, all the points, and you're trying to find out, the distance of all the points, of, the 100 points and the mean of the light blue color. Then it comes to the yellow. So it's just the calculation for the 500 times. So if you have what you call 100 point and 5 group, it will find out 5 into 100 500 distances overall. Okay. So once it's find out, okay, then you have a mean of each point. Okay, we have mean of this point. Okay.
So
yeah.
Let me tell what I understood is,
Yeah.
so every group it will find the mean. So from that mean, it will from the every point of the group, it will find the distance between the point to the mean. So if every group contains 100 points, then it will find the distances between the every point to the mean like 100 times, right?
Okay. So probably one small change. No, if your total points is 100, okay, you have totally 100 points. And here we are talking about each group is 20, 20 items, okay. So I'm saying, 20 each point has. So I don't know whether 20 or 40, but each group has some points, correct? So if you add all the points in the each group, it will come to the total points.
Okay, Sita.
Okay. So if you're confused, probably I can put a table. Okay?
No, I'm not confused. I got it.
Okay. So let me, okay, I'll make it small, okay. So this is, what you call group. This is number of points, okay, number of points, number of observations, okay. So first group, it has probably, 30 points.
30.
Second, probably have 20. Third, I have probably.
So otherwise, let's take every group is similar, like 30 each.
No, something, when you are doing initially, it will not be similar, correct? Anything can be happen. So if you look at 70, 20, I have. This is totally 100 points. Okay?
Yeah, okay, sir.
Okay. So first, when I am doing this, I take randomly 4 groups. Okay. So it has, for the 30 points, I have some mean. Okay.
Yeah.
Similarly, for 20 points, I have mean.
Yeah.
Okay. For 30 points, I have another mean. And the 20 points, I'll have mean. So I have 4 means now. Okay.
4 means.
Okay. Now, what I'm going to do, I'm going to find out, okay, when I'm doing the mean, probably, let me,
You're going to take the distance between the
okay,
mean to the every point of the other group.
yeah, every point of all the group. So,
Yeah.
if that is the
So
mean,
including that group also?
huh?
Including that group also, the mean of the
Yes,
present group also?
yes, yes. So,
Okay.
if you have
Then,
four,
then, then for each group, it will take like 100 distances. So
yes,
totally it will 400 distances then.
correct. So, 400 distance will come, okay?
Yeah, actually, I thought I'm thinking that it won't take its own group.
No, no, it will take
That's
even
what.
one group because initially you have, assign the points randomly to your own group, correct?
Yeah,
Okay. So I got, the four, what you call, four centers, okay? This is four
yeah,
centers like that I have, okay? Now I'm calculating the distance between this point to all the points, including this whole
yeah,
group. Similarly, this mean to all the points, I'm going to try to, find out the difference. Okay. Now I got 400 points. Okay, which has the distance between the various means. Okay.
means and the points. Yeah,
Okay. Now I got these 400 points. What I'm going to do, I'm going to sort all the distance by increasing order.
yeah, okay.
Okay. Suppose I assume that okay, if you sort all the points, it will be ordered in the ascending order, correct? The lowest one
Yeah,
will be, in the first one, and in the order it will keep on increasing until the highest point. Correct.
yeah,
Okay. Now it's trying to find out, okay, which distances are closest to, it try to compare, okay, if the point is closest to this point or this point. Now you have four circles, right? Four wheels. Okay. Assume that these are the 4 points. Okay. Got it?
got it.
So this is the initial mean. I'm trying to find out, once I find out the distance, I'm going to find out whether this point is nearest to this point or this point by using the Manhattan, the Euclidean distance.
Yeah,
Correct?
okay.
Okay. If initially the point is for this cluster, when I started assigning it, the first time the point was assigned to this particular group. That's why I calculated the mean. Correct. Now
Yeah,
once I find out the distance, I find out this point is closest to this particular mean rather than this mean. Okay.
yeah, okay.
So what I'll do, I'll remove this particular point from this cluster and assign to the blue cluster.
Okay.
So like that, I'm going to do for all the 500 points and find out which mean is closest to, my place.
Yeah,
So,
okay.
okay, like that, it tests for all the 500 points. It will assign to, the nearest, the mean cluster. Okay.
Yeah, okay.
So it effectively means I have removed some points from your cluster and, the cluster mean and assigned to a new cluster and you've got a new points, right, on the first row.
Yeah, okay.
Okay, so that means that you got a new points, you got some new customers, and you got, you lost some existing, the points. So now with the new points you got, you are going to calculate the new means, correct? So from the means, it will come from here to here or somewhere else, because you got a new points, you lost some existing point. When you are trying to find out the means within the cluster, the point will differ, correct?
Yes, sir.
Okay. So, similarly for all the 4 points it will do. So now it starts the next cycle. Okay. So next cycle again it does the same thing, for this particular mean to all of the 100 points, it will find out the distance. That's the second round. Similarly, this cluster will find out all 100 points, what is the distance. The point is from here to move to here, it will find out the distance of all 100 points. Similarly, for yellow color, the mean moves from this position to this position. It finds out the distance of all 100 points. Again, it will do the sorting. Okay. Again, it will do this, the distance between, which are the points are closest to this particular, mean or not, it will do like this. It keep on doing this, the calculation, until a situation comes where there no point movement will happen within the cluster. That time the K-mean cluster will stop. You got it,
Okay.
Ajay?
Yeah, I got it clearly.
Okay. So this one K-mean cluster do. So it takes a lot of time. Because if you have more points, it will take more time to calculate the distance between the mean and the distance between the point. Then that it has to do it for all the points within the data set. Then it will calculate the new mean for a particular cluster. Again, it starts the process of finding the distance, sorting, and finding your new means. It does for many number of times until there is no movement of points happening within the cluster. At this point, the K-mean cluster stops, and that's what the perfect split between the points between the clusters. Okay.
Yeah, okay.
So this is a